draw this. So I have basically a drawing that looks like this. And then it comes like kind of like this. And I'm sorry, I'm not perfect, but okay. So that's basically what our picture looks like, less the XY axis. So problem number 1 says we want the limit as x goes to -8 from the negative side. So the thing to realize is this is coming from the left. Okay, so this is where, so if I'm coming this way, this is the point, I believe, -8 comma -6. So this limit here has just an answer of -6. Seem okay so far? Then number 2, we'll do in green. If you can't decipher the difference between red and green, looks like the same color to you. All right, and I forgot to put f of x there. Okay, so this means I'm coming from the right.
He's on his way, so he hit his car in the parking lot.
Oh, jeez. He's okay?
Yeah, he wasn't there. He just watched it happen from a distance. And then he took off,
You get a plate?
which is okay. Yeah, he does.
Yeah, because didn't that kind of happen to you there in the...
And him too.
Huh, I'm sorry. All right, so this is going to be coming this way. So what is the limit with the green? Is it the same or is it different than the -6? It's the exact same, yeah. Okay.
Number 3 and number 1 seem to be the same.
I think you're exactly right. So we'll just put number 3, look at 1. Same thing. I don't know if we were meaning to have that. I'm sure it's an error. And then problem number 4, where this one gets a little bit goofy, it says, I want to know what the function at -8 would be. Okay, when you see this, this becomes an actual point and not a hole. Okay, so the function at -8 has to happen right here, which it's going to be then -3. And that's where things get different. Uh-oh. You got 1, got 2, got 3. Fellas, remind me to unmark you from being absent. Deal? Okay. Yeah.
Number 1 through 3. Because that's what we wrote right before we left to yesterday. It was -3.
I think I made a mistake. It's where the hole is.
What about the dot above it, though?
The dot above it, that dot above it, like that dot's just here. I'm not approaching it from either side. It's just there. There's no way to draw to it. So think of a limit as I can draw up to it, but I can't draw to this dot because there's not, I realize I can do dot to dot, yes, but I can't just add lines. So I might have made an error yesterday. I apologize. That's probably why I was sleep teaching last night, because I probably realized I made an error and subconsciously and had to repeat it.
So the answer is just -3?
On which one?
For 4.
4. Yeah, it's just -3.
Because you just have that point take over, right?
You just say, I want to go here in this direction without any lines. Where does that dot exist? And it exists at the dot.
So it doesn't matter.
Yeah, but if it's a limit, you're coming to it. It's like you're riding the roller coaster to it, which I guess this would be kind of a fun roller coaster. But I hope your roller coaster can jump from picture to picture. All right, we good so far there? What did we go up to? Did we go up to 6?
Yeah.
Okay. So number 5, we're going to do the limit as x goes to -2 from the left of f at x. Okay, so -2 from the left is going here. Okay, so that is going to be 3. Is that right on the... Is that my point right? But then number 6, we're going to do a different color. I'm going to jump to my pinkish color. So number 6, the limit as x goes to -2 from the right of f at x. So that means to the right. So watch what it's going to take place here. Where does that pink dot or that pink arrow seem to point forever to? Yeah, up. What's up forever? Because going up is going to positive infinity. So positive infinity is this answer. Okay? Now, I know I didn't ask you this, but this is going to tie right into number 7. Okay? Number 7 is what is the limit as x goes to -2, and it doesn't have a positive or negative. So this means it has to go both sides to the same location. All right? So let me just highlight this. All of this information here. One's coming from the right, one's coming from the left. If I come from the left, I get an answer of 3. If I come from the right, I get an answer of positive infinity. So does the limit as x approaches -2 go to the same exact location? Whether I came from the left or the right, do I get to the same spot? Well, one way I get to 3 and one way I get to infinity. Are 3 and infinity the same number? Not this week. So does this limit exist? Nope. So this limit does not exist. DNE. It's supposed to be a DNE. Okay. So I think I can wrap this up as far as the graphing goes. Pretty easy. So things to know. If it says f at and we give a number, this would be a point. Not a hole. Okay? So if I had example of something like this, this points to this. Okay, the y value of that. Does that make sense? If a point doesn't exist and they have a hole, f at that number won't exist. And it seems kind of strange, but so you're basically saying in the y direction something doesn't exist. Okay, so if I see the limit as x approaches a number and it's raised to the negative power, this means going from left to right to figure out what the limit is. The limit can be a hole. That's totally fine. Okay. If I see the limit of x going to a number and there's a positive that it's raised to, this means going from right to left. And then if you see something like this, no positive or negative. So you're going both sides and must go to the same spot. Does that make sense? All right. So what does it mean if I don't give you a picture to look at? What should you use if I give you an equation? Graph it on Desmos. And then look at what the graph looks like. Okay? Now I'm on the notes on the, let's see where we're at. Yeah, hang on. Let's see if I want to go there. You know what? What time are we at?
42.
42? Okay. All right. So I want to make sure that you're okay with, I'm just going to give an example of a problem. And I'm going to just make up that this is x comma smiley face, or smiley face can be any number, and x comma frowny face, or frowny face can represent any number. So this would be if I say f at x or f at a number. For both of these, we go to the y point, the y value of the point. If it is a limit, then we're going to go from x, and we could go from the positive or the negative side to a whole is fine, or to infinities or negative infinities are also fine. So these are all, you're looking at what the y value of the whole is. The infinities are the same kind of idea. Okay, does that make sense? Okay, so I want to give you some stuff to do. So on the page that has this, which was last night's homework.
Yeah.
So finish all of them, up to 12, because there's nothing beyond that. And then, so that's the first part. And then the second part is where it says limits 4.1, which is the second page. You can do all of problem number 1. Problem number 1 has to do with the graph, has to do with this. Does that make sense?
Mm-hmm.
So that's what I need you to work on. Ask me if you have questions. Hopefully I don't dream teach tonight.
On the 4.1, if there's not like a circle, an empty circle, should we assume that there's no hole there?
Where are you looking?
For number one, with zero.
Uh,
when X is zero.
so being that they're both converged to the same point, that limit does exist. They're both getting up there.
So
There's not a hole.
but there's a limit.
Yeah, and I'd say so. Limits kind of think about too. How high or low can you get? Well, I'm getting up to 5.
Okay.
Okay, and that's what I convey on that one. So the nice thing is the limit of 0 to the negative, 0 to the positive, and just 0, just going down, 5, 5, and 5.
Yeah.
So does the limit exist? Yes. Sounds like people are cussing at each other out there.